allot an area for HPL. Let me say that's the waste management under the simple area. So let's look at there are different handouts are given to you. Very good handouts. When you have time, just go through it. I managed to get the Australian ones, so seems to be readable. This is a fairly a good document, and to look at there are about 10 strategies they have mentioned here, right? How to address the healthcare waste management things, right? Please go through that. But there were some 10 strategies. Yeah, 10 strategies. I'll just take you through some of the things. Now, if you look at overall healthcare waste management, there are two types. Not you have liquid waste and you have solid waste. Okay, liquid waste, solid waste. All liquid waste are considered as all liquid waste in the hospital. We consider them as infected, or we call it as soiled or infected, or we consider them as soiled or infected or clinical. All fluids, all liquid waste, and generally we treat them like treating a sewer. So generally it goes to the sewer treatment plant. So that there are methodologies. We look at what are the different techniques, and there are about 3 techniques how you manage liquid waste. And if you take the solid waste, generally there are different nomenclatures, but for the benefit of us as administrators, you have clinical waste, you have general waste, you have clinical waste, and you have hazardous. We take general waste. There are three types. Right? Generally, the food containers, paper, paper and cardboard, and etc. Right? Other one is plastic, polythene and plastic. All these are non-soil or non-clinical. Clinical waste you have basically what are the areas in clinical? You have swabs, okay? You have pathological, what else? Infected material. Huh? Yes. Hazardous you have radioactive and chemical. One is radioactive and pharmaceutical. These are the basic, very basic general nomenclature. So generally, there's a rule of thumb you can use to calculate how much we produce. Generally, we liquid waste for a bed day. For a bed day, we calculate a patient would produce 40 liters for a bed day. Each patient would produce for a bed day. So this, I mean, you need not to, if you have 100-bed hospital, you have a 100-bed hospital, how much will you produce? 40,000 liters. You might think this is too much. It's not really the patient is producing. If a patient comes in, the lab would produce in terms of that, the whole hospital would produce 40. Kitchen, everything. So we don't send it to a normal drain, we put it to the all through the sewer treatment plant. As environmental authorities, they'll be very strict not to put any water out of the hospital. Only thing you can put out from the drain, water, rainwater only you can put into drain. Otherwise you can't put into drain. Otherwise, unless it's safe. And if you look at the solid waste, how much think how many kilos bed would produce? Yeah, how many kilos bed day would produce? Bed day. Kilos. Huh? Per bed day. Yeah, it's about 5 kilograms. Sri Lanka there will be more. Huh? Generally 5 is okay, safe. I did a study long years ago when I went to the Ragama. They had the largest incinerator, and our cost of uh, cost of disposal of waste was about. I did a cost analysis. It was about 12 rupees per kilo at that time. This is 2002. 12 rupees per kilo, and I found 40% of that was rice. They were burning rice using gas. So I did a lot of methodologies to reduce the rice coming in. When I inquired, there were three types of average, three types of food coming. One thing from the hospital to the patient, which anyway he can't eat, he's sick. And then one or two of the relations would bring food. All that will put into the garbage, and we take them and we burn through the incinerator. So what I did was, one thing I restricted people to come in, only one food container could take in, right? And also told nurses not to put on diet this thing, ask them seriously. So we reduce a lot input, and also I organized with one of the farms to take this food for to use for pigs and blah blah blah. So automatically I reduce 40% of the cost, around 35%. So generally about 5 kilograms per bed day. For a 100-bed hospital, how much will they produce then? 500 kilograms. 500 kilograms. Right? 500, half a ton, kilograms. This is inclusive of all. Now, if you look at the spread around this, this is the beauty of it. We always talk about clinical waste, but main thing, the whole thing, this is about 80 to 85%, and this is about 10 to 15, and this is about less than 5%. So you can have a rough this thing. How can you know what kind of a problem you are going to get into, right? And it is not rocket science, very basic, basic common sense. So I will try to show you something what I have done with the ADU. This is what I am currently working on, and then just try to brief you on the actual scenario, right? So so you have general waste, critical waste, and hazardous waste, right? Uh, right? Waste, clinical waste generated from any patient interaction. Any patient interaction. That's very important. Patient interaction. Patient or patients something, maybe blood or body fluids or etc. etc. There should be interaction in clinical waste. Right? Hazardous, chemical, radioactive, and pharmaceutical. These are general waste from the cafeteria of the etc. This is what it is. 85% general waste, 10% clinical, and about 5% hazardous. So a lot of people are scared. Actually, the whole load is here, you know. So I've seen people getting incinerators to burn general waste in vain. I mean, you have to only burn the clinical waste, ideally. Ideally. So what is the out of 500? How much is here? Clinical waste? Huh? 50 kilos. So generally, a small incinerator would cost you about 2 million. It burns about 50 kilograms per hour. That's more than I've seen massive one. So tricky thing in here is that the general waste is taken by the municipality. Suddenly, if there's a strike for the weekend, this will get stagnated with you. You have to have methodology to do that. These are the planning. We are in the planning process. We qualify waste, quantify, organize the process, and implement the condition. I'm in the process. These are the rule of thumbs I told you. So they will produce 3,500 kilograms, right? And we kept the 500 as a buffer, you know, just in case, right? So we look at 4,000 kilograms per bed day. 4,000. These are the rough measurements. So a few things. One thing, main objective is to accidental spread of infection, right? And minimize the waste production. Very important. You produce waste, and that's the cost. No? Reduce waste production. So I am pushing them to have nothing can be taken from home. With ethical issue, not really ethical, bit of a cultural shock. Nothing could be taken in. So we can put some security concerns and then stop them. Idea is not security concern. The issue is now you have this facility and you treat the patient with the uttermost care, with hand washing, blah blah blah. Suddenly a daughter will bring a soup which contains infection, and you start diarrhea. You know, so still it's hospital acquired. Within the hospital they acquire. They got this. It don't get notified. So, and it is a problem. They produce waste unnecessary, and the other thing is medically you can't eat anything. That's also a plus point you can really push across. And of course, safety, security of total waste management staff. A lot of problems can occur, and to manage the waste as per the hospital health and environmental and atomic energy authority standards. That's the other one. Then to ensure cost-effective management at all times, and to remove hazardous material equipment at the planning stage. Right? At the initial stage, right, to remove hazardous materials and equipment. One of the problems you have, what we have calculated is generally what we produce. What will happen after a while if you want to discard your CT scanner or right? So what you have to do is whatever the materials, hazardous materials, maybe radioactive, maybe anything, you should sign up with them. When you buy them, once we complete, you have to take it back after 5 years. It's very important. It's huge cost. All these radiotherapy machines, if you try to discard, it's a huge cost. Transportation and all that. So therefore, it's very important. So that's why I put this point for everyone who's getting machines. All the machines has to be discarded by the supplier. So this is a process of waste management, not to tell you anywhere. Segregation is you have to segregate waste into different areas. I will try to tell you more. You can go more into this also, different color codes and etc. Right? Then collection. First segregate. I have color coding system for general waste. First I have general waste, hazardous waste, and chemical waste. Under that you can go and pathological, infectious waste, all that you can go into. Of course, the radioactive and all. Then transport. It's a horrendous affair. I mean, I have gone through this mill when I started with Ragam. It's a huge place and boards are from everywhere. And one of the key things I identified, it's about the incinerator is about this much. Seriously, it's about this much. And first thing I realized is unlock. If I want to bump you off, I will put a small shot here, make you unconscious, put it in, boom, 2 minutes you are gone. And it burns it goes to about nearly 2000, 1800 centigrade, even not a single bone will be there. So first thing I did was to have protective system, put a security guard, put some locks, different locks, kept the key at the director's office. So these are laymen, no? Nobody has really identified. That's the first thing I did. Now yet to have such a big incinerator, huge cost. So if you reduce the production, you need not to dispose. If you talk about disposal, then storing, very important. Countries like ours, where a lot of strikes are there, a lot of holidays are there, so municipality might not take the general way. So where are you going to store them until such time before you dispose? You have to have a few horrendous affair. So you have to have to think about it when you planning stage, and of course the disposal. We are going to dispose this way. There are different types. Let's discuss as we go on. Right? Let's look at the segregation. It's critical that the waste is segregated at the point of generation. So don't even think of segregation afterwards. It's a horrendous affair. Now general waste, if you want to take general waste and try to segregate them, it's extremely difficult. So point of entry, you put into different things, different bins and segregate, separate them from the point of production, that's the best. And we still don't have that in our blood because we were not trained from small days. The other countries, even Japan and all that, from small days, pencil has to be put into pencil. Wood, they go into that level. Polythene, plastic, wood, this, that, they segregate at the point. So it's in your blood. I have about 3 bins there. I find it extremely experienced and students of some caliber, still they don't know how to put it to, So that's one of the things. So segregation, you have general waste, biodegradable waste can be food and plants and all that. So you can put into one, and of course you can recycle them. So you can use for composting, etc., etc. Lot of things you can do. Plastics and polythene should be unsoiled ones, not the soil ones. Okay, be careful with this. Unsoiled ones. And paper and cardboard. This also can be sent for recycling. Because you won't believe the amount of paper and cardboard you get for a hospital. And even the polythene, the saline, not the latter part, but the bottles, I started selling there because it's not easy to work in an incinerator of that big. So warm around, hot, and taking those ash out and all that are extremely difficult. So I told them to sell then and there, but latter part, the ministry got involved now. They collect everything and tender and send. Now it's about $110 they charge. Those days they gave $10. 2002 per kilo of polythene, polythene and the plastic. They make pellets, small pellets. They make pellets. And Sri Lanka is one of the largest exporters of pellets, you know that. It's such that they import all the garbage, polythene containers and make pellets and export. Amazing things happening. Anyway, it's a garbage country. It's going to be a miracle of garbage. So paper and cardboard, chemical waste, soiled items to be disposed. Right? Soiled items which you can't use, like others, sharp to dispose. Then hazardous waste, chemical, laboratory waste, and the drugs, of course, and the radioactive. Right? sharp contains about 10% of the chemical waste. Sharp, yeah, big amount. About if you're looking at this is you said 5 kilograms. 5 kilograms out of that 5 kilograms, about 10% is a gram. What a kilogram? Kilogram of sharps per day is a huge amount. Yeah, handling and all that. So very important to sort this sharp. Right? We do. There are different methodology. Collection has to be the sharp bins. There are different sizes. Right? Before you use the sharp bin, there are the different methodologies to use that. Right? Reduce production, the policy on water and containers, limitation of prohibition of taking food in and out. Right? Training is very important part of this. Very important to train from the word go, working. Collection, uh, security is very important in this, right? Laborers will have to have protective items, gloves, mask, and then apron to and water seal containers. Once you put it, otherwise they'll spill all over when they try to transport. Policies are important too. Equipment reprocessing, I spoke to you all. I have another presentation I will have here. Then treatment. Disposal, waste can be disposed, right? Once you collect, and before you dispose, the medical clinical waste could be treated and make it general waste. So we sterilize them. There are things called now things called hydroclavers. A hydroclaver is slightly expensive, but in a way it's a modern thing. That's what you do. What you do is you break the general waste into small particles. For maybe about 50% of the by quantity you reduce, and then put lot of steam, high pressure steam, and sterilize them. Then you can put into general waste. Otherwise, what we do is we can do incineration. Incineration is the commonest thing in this part of the world, but of course, what happens is when you do polythene and all soil polythene, everything goes into there, and this is thing called dioxins are produced, which will harm the ozone, famous dioxins. So if you are taking a incinerator, it has to have double chamber. What we do, you burn the garbage, then the air goes to another chamber, you burn that chamber also, that air also, then the dioxins will get reduced. So these standards are given how to do this and all that. Hazardous waste, there's a methodology. I have separated the handout for you all how to manage radioactive. Generally what we do, we don't get involved in that. So we take the supplier, that's in the agreement, supplier of the equipment, they take they give the containers, they collect them, and they dispose. Generally there are few types of disposal. You bury under certain feet down, or they put it into the deep sea. Yeah, they do deep sea. They put different methodologies are there. So generally we don't get involved with the radioactive material. So everything has to be get the approval from the Atomic Energy Authority. They would make sure that the process of disposal is done. Recently, I met one of these radio therapists, oncologists, and they have removed in the cancer hospital one of the tubes, radiotherapy tubes, and by the time they have stopped, and they got a new machine too. The old machine has been there. Suddenly, the lot of parts have been missing it. What this? It was all lead, no? Right? They have taken and sold it to Panchagavar. They have gone with the radioactive, these meters. and all that. They have got it. In Panchika or Idli Samna. They got all that back picture in Delhi. So these things have to be must tell these guys, how to do this. So disposal methods are given in page 8, the handout. Please go through that, right? For example, I have given here hazardous material. How do you point of view disposal, incineration, or whatever how you do those different ones. Right? There's a nice table there. So disposal method is given there. The general disposal critical waste, right? Uh, Transportation. I'll use another. There's another good presentation on this. You got a small brief on what it is. This is the one which says infectious, chemical waste management. Um, these are to minimize the spread of infection, right? And reduce the overall number produced. That's very important. Production reduced. Right? So these are the bloodborne pathogens: HIV, hepatitis B, viral infections, hepatitis C, leptospira, fever, all the malaria, bloodborne, blood to blood. Right? So infectious medical waste defined as medical waste capable of producing infectious disease. Right? Waste considered infectious when it is contaminated by organism, right? And organism is not routinely available in the environment, and the organism is significant quantity and virulence, right? But as healthcare professionals, we consider even a teeny weeny thing as infectious. You can't find out whether there was live bacteria in this. So mainly blood and blood products, soap, loads of stuff we produce, and we work in a highly tense environment, so injuries are common. Right? Laboratory waste, unfixed pathological tissues also comes in, because you take a pathological piece and you only take a piece of it to see under the microscope, rescue, dispose. So say blood products must be from a sucker, suction, blood theater. What do you all do? Go to the sink? Or what do you call that? Huh? What do you call that? It should be a not a sink. It should be a, it's called a like a we have there are links to, it's like a commode, right? Not a sink. Yeah, okay, water seal, it's sealed by water. It should be water sealed. You put into that and flush it. It goes to the sewer. The other place that you get is a bedpan washer. That we call bedpan washers. There's a machine. You put the bedpan, and that also comes in other than the general sewer. So laboratories would have it, right? And their wards would have it for bedpan wash. It is also blood product. So other things are huge amount of collection in the lab, right? Cultures, like ecological agents could be specimen, stocks, related contaminated waste, vaccine vials, all that. Right? Pathological waste here, unfixed material, you have to dispose them as the waste generated from the area of patient who has suspected having disease caused by the uh, class 4 viral agent. If you have these also, the anything produced by them. Right? Some of the things not here also. Yellow. What do you have here? Herpes, Marburg virus. I don't know what. Smallpox. That's called a white pox. Anyway, disposal of waste. So I told you they should have a disposable gown, face mask, shoe covers, right? When they handle waste. So these are the things. Here also you should have employees universal precautions, provide hepatitis B vaccination, right? PPEs used, right? And provide PPEs annually, right? Maintain records of training that can come on our things that we did. Huh? Maintain exposure control plan, reduce the exposure. I told you contact, record exposure incidents, all that. So liquid, semi-solid, these are the definitions. All fluids, we spoke about this, different fluids, right? Saliva, everything. You have to put all this in your procedure book, specifically. This is seminar fluid or synovial fluid. Looks like synovial, right? Synovial fluid. The peritoneal fluid this color. Really? Is it the white color? Huh? Synovial. Just tell us. These are general ones are not taken as personal hygiene products, diapers, cloth dressings, small amount of blood. But generally we here we consider everything as infection. We move into infection control, function from using broken glass, all that reporting has to come in, cuts and aberrations, and especially with the minor staff. They don't understand so they can get infected. So these are, we spoke about this, infected source, amount of entry, infective dose, susceptible host, filter hand washing, barrier precautions, regular cleaning, vaccination, all these. And incident response, if something happens, what to do? Collection. Right? Infection material waste must be collected at the point of generation in a color coded bag. So what are the colors we use? Yeah? Orange is what? Generally we use chemical waste is infected is yellow, no? Sharp blue, huh? Huh? Sharps, red, yellow and red, huh? Red stripes, huh? Is that pathological? Orange, orange, huh? And then paper blue, no? Paper blue, food and stuff black, no? This is brown. I don't know. Brown, no? Gray, gray or brown. Just know the color coding. Huh? Sharp, this is red what they use. What we use for biohazard symbol has to be there here. Biohazard symbol. Probably you all also going for JCI, no? Are you doing this thing? Oh, you got the. Uh, oh, good. Lanka Hospital. Ah, you all got. Durden's got. Very good. So it must be improved. It will support to improve the thing. No? So liquid infectious material. Right? Here poured down to sanitary sewer. Spoke about it. Yes, these are basic stuff. These are the records we use for waste collection and disposal. The document. There's thing called bloodborne pathogen spill kit. Something if you spill something, these are the stuff you have to have. We all have this. See, there's another business coming in, no support supplying these stuff. Sometimes you overclassify basic general waste, then they put into uh, clinical waste and overburden the disposal system. So that's what it is. Cardboard and all that you need not to put into the this thing because that can be before you use, no, before you use. The top part need not to put, no, only the bottom part you can cut and put, no, isn't it? Is it right? Yeah, they go to chemical. These are routine overclassified items: IV bags, paper towels, wrappers. These are the things administrator really should analyze and see waste analysis and give a proper. So, I'll show you some. You get an idea, no, roughly what's happening. Know about how to develop a waste management system for a let's say 100-bed hospital. How to approach this, you should know. So this we went through. Let's look at the liquid waste. Go to collection, liquid clinical waste, bedpan washers. I told you, special pipes to collect, radiological chemical specific container, right? Fluid, radiological also. Another chemical, it comes in fluids. No? They should be collected into separate container. Transport, the non-corroding pipe, that is the transporting. Special container to leak-proof, radiological protected one. Storing and special area, secured area, and disposal as per the category. Right? Um, so these are the three main processes that would take place when you try to dispose liquid waste. First we disintegrate, then put some chemicals. Right? It can go either way, but first one is disintegrate. Right? Then biological degradation can be aerobic with oxygen, with bacteria which use oxygen, or anaerobic. So these are the three main activities happening. levels of treatment. Right? Primary treatment is the removal by physical separation by the large object. Primarily you remove all the bigger objects into a small object, right? Secondary, then you put into microbes. This is secondary process, aerobic or anaerobic, Uh, so tertiary is anaerobic. First what you do is you degrade, you put fans and big fans, and you try to degrade into small particles, and it's good. Then the bacteria can act on this more quickly than the smaller particles. Then you do aerobic, you put a open one. Again, you slowly mix the tour with where the bacteria are. And then this tertiary one is called advanced anaerobic. Bacteria would again act and disintegrate. Right? So they put methanol and stuff to grow the bacteria and all that. There are few things happening. So finally, what you have is a thing called a sludge, like a tar kind of a thing. You can use it for fertilizer, right? Or you can incinerate if you want. You can use this as an incinerator fluid, fuel. So these are the three processes: right? Physical process, chemical process, biological process. If you know this, that's fairly enough. Right? Screening and sedimentation and the filtration, physical process. Um, uh, Once you take all the bigger particles, then sediment and filter and degrade. Then chemical, once the precipitation or the chlorination. You can put chlorine and kill whatever the other bacteria is available. Then biological processes, aerobic and anaerobic. Those are the things. Just know roughly what's happening. Huh? It's the same thing. Sharp. What will you call a guy who's managing waste? Same thing. Huh? Person who's managing waste, what do you call it? Huh? What do you call it? Not boy, teacher and this boy, what's your father's profession? My father is a waste manager. There are some pictures on incinerators in Indian. They're recapping, that's what they do. They try to put it back. Universal precautions, using the mask, but he doesn't have it. Paper. It's very dangerous. This coat will carry all the germs under the sun. And the ties, ties, they do that when the tie would touch. This is, of course, blue container, red, yellow, and black. There's a needle recycling. You can put there, and then if you you can break the needle. Puncture proof container. Blue, no? Here they have used blue. We use yellow and red. that. What do you all use? Glue for paper. Cardboard box. No, and then the needle stick injury happens at this particular moment. Uh, Now I haven't seen many days, but people used to do mouth sympathy, okay, blood and all that. Infected sample, protective gear. Now this one is using, a lot of blood. Like a Dracula face. Specimen selection and strict access, very important. Disinfect, right? Put it into chlorine, hypochlorite. Autoclaving, biowaste, they do that also. Autoclave, bottles and all that, what we use for blood collection and all that. We do that in the hospital. Small, thousands of bottles, small ones, collect blood. Yes. Protect healthcare worker, no gloves, nothing, no. Is where, yeah, there's gloves, no? But no apron on the glove. Steam laundry, my God. That's Indian. This is an incinerator. Yeah, massive incinerator. Must be having two chambers here and there. Right? There's a blower, and this is and then the chimney goes up. This is the ash to produce. To be disposed. So those are the in nutshell. That is that. So ideally, you should be able to manage waste